Welcome to the AIA structural modules. This is module 6, where we'll be talking about trusses. We talked about trusses in module 5 using the method of joints. In this module, we'll be using the method of sections. So let's take a look at an example problem using the method of sections. And I'll show you why method of sections is such a valuable tool. Let's take a look at a truss which is a bit more complicated than the last example. And so this truss, we have statically determined two reaction points, A and B, and we have multiple bays. We have 1, 2, 3, 4, 5, 6 bays. And even though I'm not drawing it exactly to scale, they're supposed to be equal, but that'll be okay for purposes of this class. So we have our top chords, our bottom chords, diagonal chords, and let's put some dimensions down. Ten feet, and we'll make these all equal bays. 6 bays at 20 feet, so 6 at 20 feet equal to 120 feet, and 20 feet high. And we'll put some loads on here, so we'll have 20 kips, 20 kips, 15 kips, 10 kips, 10 kips. And we're going to calculate the load in one member, member number 1. Now if I had to do this using method of joints would be rather cumbersome because I would have to solve all of these joints in order to get to member number 1. Method of sections allows us to get there a lot faster. But let's first calculate the reactions. And you can use that shortcut formula that I gave you earlier in one of the previous modules to calculate the reaction because I've got my point loads here. And so the way I can do that is I can use the ratio of the spans. So 20 kips, the first one, it's the ratio of the distance to the right-hand span to the total span. So my total, because I have 120 feet and they're all equal bays, I can use a very simple fraction. Each one of these bays is 1/6 of the total span. So from the 20 kip line all the way to the other end, which will be 100 divided by 120, or 5/6, plus 20 times 4/6, plus 15 times 1/2, plus 10 times 2/6, or 1/3, plus 10 times 1/6. And all I'm doing there is I'm just taking the ratio of the spans using the shortcut. So I'm going to put a little parenthesis in here, shortcut method, and you should go back and take a look at the previous module if you haven't seen that already. So let's see what that calculates out to be. So 20 times 5/6 is 16.67, plus 2/3, 0.67 times 20, 13.4, plus 7.5, plus 3.33, plus 1.5, or excuse me, 1.67. So what does that equal? I have 16.67 plus 13.4 plus 7.5 plus 3.33 plus 1.67, 42.57. Okay, so 42.57, and in order to calculate the force here in member 1, what we're going to do is we're going to cut a section. That's what that's called, method of sections. We're going to cut a section right about here. We'll call that XX, because we can see by looking at that section that if we sum forces about this point, we're going to cancel out all the unknowns. I'm going to label this sheet as sheet number 1, and let's go take a look at sheet number 2. And that's the beauty of method of sections. So by looking at this free body diagram, drawing it again rather simplistically, I can draw my first 2 bays. And I don't have to worry about all these loads in here, because all I'm trying to do is solve for P1. And these 2 loads, which for right now I'll call this X and Y, are the 2 unknowns. And the reaction A we've already determined is 42.6 kips. And we know that the load here is 20. And we know the load here is 20. If I sum the moment about this point here, which is the center line of my truss, we'll call that point C. And I have all of the dimensions here already in place. Because all of the bays are equal. So this is 20 feet, 20 feet, and 20 feet. And I have the height already in place. And the height is 20 feet for point P. This is called method of sections. I'm cutting a section through the truss, which allows me to eliminate the unknown so I can get one particular member size, or one particular member force. So summing the moments about point C equal to 0, clockwise positive, I get plus 42.6 times 60 minus 20 times 40 minus 20 times 20 plus, because P1 is going clockwise, P1 times 20 must equal 0. These 2 unknowns cancel because they don't have a moment about point C. And so using that, we can now calculate what our numbers are. So we have 42.6 times 60 2,556 minus 20 times 40, 800 minus 400 plus 20p1 equals 0, or 20p1 equals minus 2,556 plus 1,200. So we have 1,200 minus 2,556 gives us a negative 1,356. And so P1 equals 1,356 divided by 20 minus 67.8. Now the fact that it's minus only tells us that it's in compression. We assumed it to be in tension. But the fact is that it's in compression. That's all. That's not a big deal because the sign will automatically correct you. We got that answer in basically one step without having to solve the entire truss. That's the method of sections, and that's the advantage of using the method of sections. Thank you.